This video is recorded for ins4051 mathematics modeling. My name is Cho Yi, and my student number is 1150164. The particular problem with scientific context is wave interference. Interference is the fundamental concept of wave mechanics. When two or more waves meet each other, constructive or destructive interference takes place, which leads to the formations or complex intensity distributions. So for this project, the objective is to create a computer program which can effectively calculate the interference pattern created by multiple scores of waves and visualize the intensity distribution of the interference pattern. And this is the sample question. I take it from DSC choose 2021, and this the question I want to explain for students. And why this is the important problem to solve? Because it is related to physics education, engineering application, scientific research. First, for the physics education, interference is an integral part of physics curriculum for secondary students, and the use of visualization tools can help students better understand abstract concepts like waves, thus improving the learning progress and generation interest in the subject. Second, the engineering application, such as sound engineering, involve the precise control of interference patterns and simulation tools could be used to speed up their design progress, those cutting costs. For scientific research, from the famous double-slit experiment in machine to study the cosmos by video oscillation interference is a curious part for scientific research, and precise simulation is helpful in the verifications progress. And in the real life, it is some applications such as photographic instrument and the accuracy engineering. For photographic instrument equipment such as interferometer, holographic system, and the ferrite optic sensor relies on a pressure control of interference by desiring the thickness and refractive index to ensure that reflected light cancels out while transmitted light reflects. Those device minimum reflections project clear information and achieve higher brightness, make them suitable for precision measurement, imaging, and materials analysis. This is a sample of the interferometer. And for the acoustic engineering, active noise cancellation technology, sound system design, and architecture, acoustic optimization, all involve the calculation and control of sound wave interference. Ensure that unwanted frequencies are cancelled out within the system to enhance sound quality and speech clear. This is a sample of the active noise cancellation technology experience expectation. The mathematical tools I'm used is GeoGebra. GeoGebra is a very useful and efficient tools to make the mathematics modeling. And this the step I make the GeoGebra. First, I make 5 lines, D, lambda, and Yn, and end up. D is the distance between S1 and S2. Lambda is the wavelength, and is D defined lambda. Yn is the y coordinate of the observation screen, and n is the number of wavefront circle displayed. Then I create 2 points to mean the pace. S1 equal to negative D divided 2, then y is 0, and S2 is D divided 2, y is 0. It's the score positions. Then we create a wavefront circle, like these 2 formula. Create a circle screen that will create a spheroidal some circle within S1 and S2, and then the number of that will create. And wave A is the wave from circle S1, and the wave B is the wave from circle of S2. Then we will create the anti-lambda lines. It means the pattern difference with how many lambda. It will an integer without 0.5. Lambda lines is the pattern difference and plus 2 divide 1 lambda. I enter wrong in there. And then just like the anti-lambda line formulas, enter sequence and then Hilbert line S1, S2. Then, but it will some different because it will K will add to the 0.5 and 0.5. Then the intersection point with the observation screen is for marking it. These 2 line is which lambda. So we will just add it like these 2 formula. And then in After we finish some foundation we need, then we will create a P point. Is for just testing which lender will find. Create a point P, line P with S1 and S2 is for the distance with the P with S1 and S2. So we will calculate the distance, distance P and S1 minus distance P and S2. The N2, because in front we have a N4, so we need to change this to distance defined lender. Is the difference expressed in units of P, a lender of P. Okay, let me show you my project. In this website, we can see we can show the lender line or not, show the anti-lender line or not, show the wave form or not. And we will show the time difference of P in units of lender, and we can change the wavelength of the inside line. And the distance between S1 and S2 we also can change. And we can show the pattern difference or not, or show the distance between P and S1 and S2 or not. Because it is for some student, maybe they cannot handle of this topic. Just for the previous sample question, it will say change this wavelength or not. If this wavelength from 5 change to 2.5, we can see the between the Nando line and the anti-Nando line will be shorter or smaller. And if we change the distance between S1 and S2 from 10 to 5, you can see the number of the Nando line and anti-Nando line is become lower. It's become will become small. Yeah, the number of the anti-Nando line and the anti-Nando line will be small. And the distance, because maybe sometimes they will find, so it can show or not. But for the future area or future improvement, I think it's 3D simulation and the performance optimizations. First, for the 3D simulations, extend to full 3D interference simulation, providing a more realistic reconstruction of physical scenarios suitable for acoustic and electromagnetic applications. And for the performance optimizations, employ CUDA or OpenCL to achieve GPU accelerations, enabling the progress of larger networks and more waveframe for real-time simulations of complex scenery. And this is my reference, and thank you.